Hey everyone, Mr. Fransky here. Today we're going to be doing 4.1b. It's called dimensional analysis, which is really just unit conversion. We've done a little bit of this already. We've dealt with changing between degrees and radians, and we've also done degrees, minutes, seconds. So we've dealt something with like 60 minutes to 1 degree, or 1 degree to 60 minutes. We dealt with 180 degrees to pi radians, or pi radians to 180 degrees, and this is just the tip of the iceberg. There are an infinite number of unit conversions in the world, and we're going to kind of touch on a few more of them today having to do with rotational kinematics, kind of. So it's a little bit of physics, actually, which is kind of cool. All right, so first let's do some bell work. So arc length and conversions, these are things that we've seen before. So if you want to pause the video and try them, then we can try them together. All right, let's see how we do. So we're going to convert these to degrees. So we have first 7 pi over 12. Remember, when there's no units there, it must mean radians. So we got 7 pi over 12 radians. All right. And now I want the radians to cancel. So I want the pi on the bottom. I'm going to put the 180 degrees on the top then. So the radians, which are invisible, are going to cancel. And then we have the 180 degrees. We'll end up with degrees here. So I'm going to rewrite this like this. 7 pi, 180. Put the 12 on the bottom. We got a pi here. So the pi's cancel, which is nice. So we have 7 times 180 over 12. Grab a calculator for this, but I'm going to see if I can do this. Let's see, 180 over 12 I'm looking at. I'm going to divide them both by 2. So this is 7 times 90 over 6. Divide them by 2 again. 7 times 45. So I'm just pulling out basically 2's from these numbers and canceling them. So 7 times 45 over that would be 3. 45 divided by 3 is 15. So 7 times 15, which is 70 and 35, 105 degrees. Let's see if that makes sense. I should be just past pi over 2. Yeah, this is just past 6 pi over 12. So it's just a little past pi over 2, the top of the circle, 105 degrees. All right. Next up, 2 radians. So 2 radians times 180 divided by pi. So 2 times 180 is 360 degrees over pi. So we could just leave it like that, or let's go to a calculator and see what we actually get here. So if I go, I have my Inspire up, but you guys could use a scientific calculator for this for sure. So if I do 360 divided by pi, pi is next to the h right there. There we go. Control enter, get an approximate. Gives me 114.59 degrees. Remember we said yesterday that 1 radian was about 57, so I buy that. All right, now we got a degrees, minutes, seconds. So we have 214 degrees for sure. So we want to change the minutes and seconds to a decimal. So we have 47 minutes. 60 minutes to 1 degree. Remember, I want those minutes to cancel. So 47 sixtieths. I'll go to my calculator in a second. Let's get the other one first here. So we have 22 seconds. Remember, there's 2 ways you can do it. You can do seconds to minutes, then minutes to degrees. I'm just going to do 3,600 seconds to 1 degree. Okay, so let's go to our calculator now and calculate both of those. Come on, there we go. So we got 47 over 60. Gives me, control enter, 0.783. 783. Oops. And then 22 over 3,600. Gives me 0.00611. So we're going to add these to 214. So 214 plus this guy plus this guy. So 214, you go up and grab those guys. Just add them together. And this guy as well. Gives me 214.789. So converted to decimal degrees. There we go. Not too bad. Okay, next up, we're converting to degrees, minutes, seconds. So we have 108 degrees for sure. Okay, and then we need to deal with this 0.315 degrees. So 0.315 degrees. 1 degree is 60 minutes. So we're going to change to minutes first. So 0.315 times 60. 0.315 times 60 gives me 18.9. So we've got 18 minutes. Now we have to change that 0.9 minutes to seconds. So 1 minute is 60 seconds. So do 0.9 times 60. I think that's going to be 54. Yep, 54. I knew that because 1/10 of 60 is 6, and this is 1/10 short of 60, so 54 seconds. So we have 108 degrees, 18 minutes, 54 seconds. There we go. All right, so not too bad there. Next up, arc length. So remember when we do arc length, we have a piece of the entire circle. Oh, sorry, well, I guess I'm doing this one first. That's fine. We're already here, so let's just talk about it. So we have a piece of the entire circle, 50 degrees, divided by the entire circle, which is 360. That'll tell me what percentage of the circle I'm using here. We're going to multiply that by the entire circumference, because I have just a percentage of the circumference. That's 2 pi r. R in this case is 12. So let's see here. We have 24 pi times, that's 5 out of 36. Get rid of the zeros. So let's go to our calculator. So we have 24 pi times 5 divided by 36. It's like 10.471. Now let's see if that kind of makes sense. This is short of 1 radian, right? Because 57 degrees would be 1 radian. 1 radian would be exactly 12, so it's a little short of 12. I buy that. Convert this guy to radians. So we have 255 degrees. Remember, radians and degrees somehow uses a pi and a 180. Looks like we need the 180 on the bottom. In this case, pi on the top. So if I got my calculator, that's a 255, I promise. Do 255 times pi, multiply across the top, and then divide by the bottom, which is 180, gives us 4.45 radians. Remember, you don't need to write radians, but when there's no pi there, sometimes I like to do it because it makes it clear what you're talking about. Cool. All right, let's talk dimensional analysis. So like I said, this is really just unit conversion. And so the point here is that pi over 180 and 180 over pi are just kind of the beginning. All kinds of other things you can use. So these are keynote points that you're definitely going to want to have in your notes. First one is that equivalencies work both ways, right? So 180 over pi or pi over 180, as long as you have the units canceling that you want to cancel, you can use them either way. Okay, so for example, like 1 yard is how many feet? 1 yard, I think, is 3 feet. You can also use that 3 feet is 1 yard. Okay, so you can use them either way. 1 radian is equal to the length of the radius. So if you have a circle of radius 5, you might at some point use 1 radian is equal to 5 units, or 5 feet, maybe, let's say. Let's say this is feet. So you're going to change radians to yards. 1 radian is 5 feet, 3 feet to 1 yard. Kind of cool. All right. Next one, 1 revolution is equal to 2 pi radians, or 360 degrees. So that's going to be one important one as well. If we have 1 revolution, you can do that to 2 pi radians, or you can do 1 revolution as 360 degrees, depending on which one you need to use, or 2 pi to 1 revolution, or 360 degrees to 1 revolution. Okay, so remember, you can use it either direction, and 1 revolution is an entire way around, so that's 360 degrees, or 2 pi radians. So let's do some problems. I think I have 2 of them queued up. So a truck has 36-inch diameter tires. They rotate at 630 rotations per minute. Find the speed in miles per hour. So we're given rotations per minute. We want to change to miles per hour. Now, the first time you see this, it could seem kind of daunting, but it's really not that bad. So you have 630 rotations per minute. So I'll write that as rotations per minute. Okay, so 630 rotations in 1 minute. We're going to change to miles per hour. So we're going to think about dealing with these as 2 separate entities. Let's deal with the minutes first. The minutes, I think, are easier to deal with. I don't want minutes at the end. I want hours. So let's see here. I need something kind of conversion between minutes and hours. Well, I know there's 60 minutes in an hour. So which one do I want on the top? I want the minutes to cancel. So I have 60 minutes up here. It's the first time we've seen something I want to cancel on the bottom to 1 hour. Minutes cancel, and I now have hours. That's exactly what I want on the bottom. So now I'm going to use the same box to keep going and get rid of those rotations. So let's see here. 1 rotation, or I guess I should have called this revolutions, really. Okay, let's call them revolutions. So 1 revolution, we said, is either 2 pi radians or 360 degrees. In this case, I think I wanted to use radians because, let me tell you why. You could go to degrees and then change to radians later, but because we're going to talk about the diameter of the tires, 36, I want to actually relate that distance to the distance around the outside. So I think radians are going to be a better choice. Okay, so 1 radian, right, we're just trying to get these to cancel, is how much? Well, it's not 36, it's 18, right, because it's the length of the radius, so 18 inches. Now I got to change inches to miles. Oh boy. All right, well, let's see, 12 inches in 1 foot. How many feet in a mile, you guys know? I had someone tell me once it's 5 tomatoes. Let me explain that. I'm just an E in tomatoes. Okay, 5 tomatoes, because it's 5280. 5 tomato, 5 tomatoes, 5280. I don't know. If it helps you, great. 5,280 feet in 1 mile. Let's see if everything cancels. We can cancel dance it out a little here. So feet goes away, inches goes away, radians goes away, revolutions go away, and we end up with miles on the top and hours on the bottom. Okay, now, so the way you do this, the way I like to do it is just multiply everything across the top, get a number, multiply everything across the bottom, get a number. In this case, we just have 1. It's not too bad. And then divide them at the end. I think that's the easiest way to do it on the scientific calculators. So let me get out of here. Go to my calculator. So on the top, we have 630 times 60 times 2 pi. Pi over here. There we go. Times 18. Give it a number. So it's 1360800 pi. On your calculator, you'd actually get a decimal up there. And then on the bottom, we have 5280. Oh, oops, actually we have, this is a 12. Sorry, it's not a 1. I thought that was a 12. There's a 1, it's a 12. So we actually have to do 12 times 5280. So we have 12. Oh, come on. There we go. 12 times 5280. Gives me 63360. Okay, so we do the pi divided by the 30. And let's see what that gives us. 67.472 miles per hour. So maybe speeding a little bit. Okay. Now, the reason I call this street legal is because one of the things that's required to make a car street legal is to have the required size wheels on the vehicle. That's because your odometer is the thing that measures the number of miles your car has gone. It does not actually measure how far you've gone, right? It can't actually tell how far your car has gone. What it can tell, though, is how many times your axle revolves around, right? So every time your axle revolves once, it thinks, okay, that's 1 time around, so how far have you gone? Well, it can only know that if it knows the size of your tire. So if you have tires that are too big on your car, you're cheating, right? And it's also dangerous because it puts a lot of stress on the axle. But if your tire is bigger than it's supposed to be, 36 diameter, inch diameter is pretty big. If your tire is bigger than it's supposed to be, then every time your axle goes around, you're actually moving farther than your odometer is going to say. So kind of a cool little side way that your car uses math, actually, to be able to figure out how far your car has gone. All right, this one is on your blue sheet. It's number 6. So a Ferris wheel has a radius of 30 feet. You clock 1 revolution at 20 seconds. First thing they ask for is angular speed in radians per second. You do not have to know what angular speed is. You just have to know that you're looking for radians per second. This is a great way to get through physics if you struggle. It's just to kind of make it work for the units. So what we're told is we have 30 feet in 20 seconds. Sorry, 1 revolution. 1 revolution in 20 seconds. We want to change that to radians per second. Well, I already have seconds on the bottom, so I'm good there. But I have to change revolutions to radians. So that's one step. 1 revolution, 2 pi radians. Radians, D. So 1 times 2 pi, so we have 2 pi on the top. On the bottom, we just have 20. Looks like pi over 10 radians per second. I'm just going to leave it like that. So every second, you go pi radians, I guess. Or every 10 seconds. Okay, now they ask for the linear speed in feet per second. So I have pi radians in 10 seconds. I'm going to change this to feet. So let's see, 1 radian in this case. Remember, 1 radian is the length of the radius. That's 30 feet. Okay, so we have 30 pi over 10, which is 3 pi feet per second. There you go. So all the problems on that blue sheet are kind of like this. They're not really too bad at all. That's it for dimensional analysis, I believe. Let's just double check. Yep. Love you guys. That's why I'm here. Have a great day, and I'll see you in the next video.